Today we're going to talk about significant figures, also called significant digits. So I will refer to them as SIGDIGs or SIGFIGs. When I went to college, we were called significant digits. They've now been renamed to significant figures. It has to do with measurements and how accurate your instrument is, basically. And so what we're going to use it for is a method for how we're going to round our answers. Because many times our calculator will give us a very, very long answer and we don't want to write all those numbers down. So we're going to learn first to identify significant figures, and then we're going to learn how to round our answer depending on what mathematical function we are performing. All right, so let us begin. So you don't need to know the definition for me, but just in case you're curious, a significant figure or digit is a measured value that is known with a great deal of certainty and also could be estimated to like a decimal point. For example, now this is a ruler that's blown up, but we could say with great certainty that this is over 3 centimeters in measurement. It's actually over 3.5, and this is 3.6, 3.7, 3.8. So we could say with pretty great certainty it's 3.8 centimeters. And if you look really close, it's not quite to the halfway point, so maybe like 3.84. So we could estimate that 3.8, that 4 we could estimate. So that would be considered a significant digit. So what we couldn't estimate is 3.845692. So that's really what significant figures are. It's really how accurate our machine that we're dealing with. Our scales, a lot of times they'll go either out to the 10th or they'll go out to the 100th, and that's as accurate as our measurements can be. So that's why all these silly rules, I say silly because I was very scared of them when I went off to college. I've now learned they're really not that bad. So we're going to go through the rules and hopefully you'll understand. It's just going to be a method for our rounding our measurements as we take measurements in lab or as we see measurements or problems throughout the lecture. So our first rule, and you can always pause this also will be up on Moodle for you, this PowerPoint, but our first rule is all non-zero numbers are significant. So our zeros are going to be what's giving us making it a little bit more complicated. So if it's a number 1 to 9, doesn't matter positive or negative, it's considered to be significant. So what we're going to do first is just count significant figures. So the number 16, those are both non-zero, so this would have 2 significant figures. The number 243 would have 3 significant figures. So if it's a number, super easy, it does count. So then it has to do with those silly zeros. Where the zeros are is going to determine whether or not it is significant, and whether or not a decimal is present is going to determine whether it's significant. So it says zeros are significant when they're between two non-zero numbers. So these are going to be zeros that are in between two other numbers. And so anytime they get sandwiched in between, they're going to count as significant figures. So the number 207 does have 3 significant digits. These zeros here between the 5 and the 3, they're all going to count. So that's going to have 5 significant figures. Even if we had a number like 4.0009, doesn't matter that decimal's there, they're still going to count, and this would also have 5 significant figures. So zeros in between two other numbers are significant. So then we have something called trailing zeros. So trailing, if you're trailing someone, that means you would be behind, right? So trailing zeros are only going to be significant if there is a decimal present. That's important. So if you see a decimal, then it's going to be considered a significant zero. So we see a zero, we see a decimal in this number. These are trailing zeros. So this would have 4 significant digits. These are also trailing zeros, but I don't see a decimal, so therefore this only has 2 significant digits. This is also a trailing zero. Trailing doesn't mean it has to be after the decimal, so I want you to understand that. Trailing does not mean it has to be after the decimal. Okay, it just means it's the last number in the digit form. So this is after the decimal. I'm not after the decimal, but is after the number, so it is a trailing zero, and there is a decimal present. So this would be 3 significant digits. This one, 960 with no decimal, would be 2 significant. And some of you are thinking, well, isn't that the same number? 960 with a decimal, 960 with no decimal. It technically is. The difference is this is an exact measurement. If I put that decimal there, that was exactly 960, maybe centimeters, meters, whatever we were measuring. This is approximately 960. Could have been 959, 961. So this is an approximation. This one is an absolute. So that's the difference between them. So if you see trailing zeros, meaning after the end, so whether it's a decimal or not, so like 400.00, see all those trailing zeros there, this would have 5 significant digits because we do see a decimal present. Okay, so that decimal is making a difference for trailing zeros. All right, the next rule is the one I don't really like that much, but it's one that students miss the most, and I guess that's why I don't like it. But it's about leading zeros. If you're leading the pack, you're in the front. So these are zeros that are in the front. So if we start a number with a bunch of zeros, these don't count as significant. So this would be just 1 significant digit here. And do you see these two? These are in the beginning, so these are not significant. Now this one's significant because it's a number. This is significant because it's a number. This one's in between 2, so that's going to count. And this is a trailing zero, and there is a decimal present, so this would be 4 significant digits. It's a little crazy, isn't it? So you will catch on, and it's really not that hard if you can just remember. This again is the most missed question here, is that leading zeros are never significant. Students will miss that most of the time until you catch on. All right, and then we're going to use lots of scientific notation. So anytime you have a number times 10 to a power, then this is known as the coefficient, which is the stuff that's in before the times 10 to a power. Then that is going to always count as significant. So these would be 3 significant digits. So if it's in scientific notation, the reason we put things in scientific notation, we use that to say that those are all going to be counted as significant. And I do want to make sure you can take things in and out of scientific notation. So if you have trouble with that, please let me help you, and I can show you with your calculator how you can do that very easily, because we will be using scientific notation quite a bit in class. All right. So now what are we going to do with that? Well, once you can identify how many significant digits something has, then we're going to either be multiplying or dividing, or we're going to be adding and subtracting. So there's 2 different rules. So when we are multiplying and dividing, sometimes our answer, again, comes out really, really large in our calculator. We're going to round our answer so that it matches the least amount of significant digits that was in the original problem. So when we are multiplying and dividing, we're going to round so that it matches the least amount of significant digits in the problem. When you're adding and subtracting, you're still going to round. It's still least, but this time it's going to be about decimal places. It is called a significant digit rule, but it's really not a significant digit rule. It really is an adding and subtracting rule, or a decimal place rule. So again, when we multiply and divide, it's least sigdigs. And when we add and subtract, it's least decimals. Okay, and I'm going to use an example here in a moment to make you, hopefully you understand that one. All right, so I have some little examples here. And so I'm going to go ahead and we're going to do the multiply divide first. And then we'll do the add and the subtract. Okay, so if we have 5 times 2, we know that 5 times 2, of course, is 10. Okay, but if I write 10, you're actually going to get that marked wrong. And because I'm not checking your math facts that you know that 5 times 2 is 10, but rather that you know how to apply the significant digit rules. Again, we are multiplying in this case, so we want to round our answer so that it matches the original problem to the least amount of decimal places. So for instance, this one has 2 significant digits. That's a trailing 0. There is a decimal there. This one has 3 significant digits. So we want our answer to match the one with the least amount of certainty, we say, which is 2. So we need 10 to have 2 significant digits. So right now it only has 1 because there's no decimal. And many times students will go 10.0. Well, then now it's going to have 3. So that's not correct. So the only way you can have, there's 2 ways you could actually make 10 have 2 significant digits. One is just to put a decimal there. That works. Or you could put it in scientific notation, and that works as well. So you can always put numbers in scientific notation, especially when we use the multiply and divide rule. You can do that. I'm going to encourage you not to do that when we do the add subtract, just because it throws off the decimal place. So you can use scientific notation, multiply, divide. When we add and subtract, I'm going to suggest you don't use scientific notation. We also don't use scientific notation for like temperature or money or percents. Those are things that we don't use scientific notation for. All right, next one, we are dividing. And so multiply, divide, again, is least sig digs. So this one has 4 sig digs because those are trailing zeros after a decimal. And this one has 3 sig digs. So we want our answer to match the one that is the least. And of course, 9 divided by 3 is 3, but I needed to have 3 sig digs and still be 3, so I put 0.00. Okay? All right. So these two were least sig digs. Now we're going to add and subtract, and these are going to be least decimal places. Okay, so I'm going to kind of use that first one as an explanation because this one I hope was going to make sense to you. Grams, we measure grams with a scale, and so sometimes in our classrooms we have scales that go out 3 decimal places. They're really good scales. But then I have some, they're good, still good scales, they're just not as great of scales. But sometimes the scale will only go out 1 decimal place. So first off, in lab, never use 2 different scales. That's a rule. Don't use 2 different scales. Always use the same scale. So, and whatever scale you start with, you stay on that scale. But if we were adding 2 masses and one person had this scale and another person had this scale, and I said, what is the mass of those 2? You could not tell me with absolute certainty this was the exact mass of these 2 objects. And the reason you couldn't is because this scale, we don't know what the 100th and 1000th place is. We don't know. So you can't say with any certain degree of certainty that this is the mass of these 2 objects. You're only as good as your weakest instrument. Just like in sports, you're only good as your weakest player, they say. So our weakest one, or our scale that could measure the least accurate, I guess, would be the one that could only go out to the 10th. So we can only go out to the 10th spot for accuracy. And so we do round because we're going to round. And so 5 or more, we are going to round up. So this answer for this one, I guess I need to go back to y, would be 11.5. No, it would not. So sorry. It would be 11.4. Sorry, I looked at the 5 and said 5. And then it would have the unit of grams, because when I add a gram and a gram, they do come out with the unit of grams. Okay, that's the adding. It has nothing to do with sig digs. It has to do with decimal places. All right, I'm subtracting. And so this one goes out 2 decimal places. This one's going out 3 decimal places. So we want our answer to only go out 2 decimal, and it does need to go out 2 decimals. Well, 12 minus 6 is 6, but we would put 0.00, and then a meter minus a meter would get a meter. All right, those are the 2 rules. So what I have on this next slide, I'm not going to go through it, but if you want, this was an old homework that I had. See if I can get it to show. Well, it's not cooperating real well. There we go. So if you want to pause right here and see if you can do those, so pause the video, maybe on a sheet of paper, see if you can figure out how many significant digits these have. And then in just a minute, I'm going to have the end answers there for you. And then you can ask questions in class or email me if you're like, I don't understand why, number 30 was, 1 or whatever. So, but if you understand it, that's great too. All right, so if you want to pause the video, there's just 40 little practice there. And then the next slide, there are just 5 little practice problems of this. If you want to pause the video, see if you could add, subtract, multiply, or divide, and see if you can get the right rule for rounding your answer. It does say correct amount of significant digits, but that's just because that's what it's called for the rule. So you're either using decimal places if you're adding and subtracting, and at least sig digs if you're multiplying and dividing. So if you want to pause and work on those. If not, here are the answers to those. Here are the answers to the 1 through 40. And again, you can pause this and check your answers. And here are the correct answers for 41 through 45. So since we're talking measurements, let's do some vocabulary. Here's 2 words. You might want to pause, write these down. But the difference between a quantitative and a qualitative measurement, or lab, I should say. Quantitative is actually a measurement when you measure how many grams something weighs, how many centimeters, what was the temperature. So basically you are taking something that would have numbers to it. So quantity, if I said the quantity of the apples, you say there's 5 apples there. So a quantitative lab would be a lab in which you are actually taking measurements with scales, thermometers, etc. A qualitative lab is a lab where you are just making observations. You're not really recording numbers. You're saying, well, like the apples are red, or they're green, or the car is blue, etc. So qualitative is more not taking measurements. It's the easiest way to say it. So qualitative would be like the quality of the substance. So you're just making observations. Quantitative, you're actually taking down actual numbers. So, and then 2 more words is the difference between accuracy and precision. So us, when we talk just normal, we say, oh, it looks very accurate, or you're being precise. But these terms really are different from one another. If you're accurate, you are being like really close to what the answer should be. Your measurements are close. If it was supposed to be 4 centimeters and you got 3.9 centimeters, that's pretty accurate. Precision, on the other hand, is just repetition. You really should do a lab more than once. Now, when we're in lab, sometimes we'll only do it once, mainly for time's sake, but precision would be repetition, repeating the experiment many times and getting about the same answer every time. Okay, so you can be have precision and not necessarily accuracy, because if your scale is off a little bit, I think the scale of my house is off a little bit, and so every time I get on it, it shows great precision. It's about the same number. I just don't think it's the right number. Now that's just me. So that's the difference between accuracy and precision. So I like this little picture of a dartboard. So most of you probably thrown darts before. So that first one, you can see those arrows, those 3 arrows are all over the place. So there's no precision, not hitting about the same spot. Accuracy would be hitting the goal, which would be the center. So this one is almost accurate, but there's no precision going on with this. Now here you'll notice we're hitting that yellow every time, about that same spot, and so that's being pretty precise but not necessarily accurate. Accurate and precision would be doing the experiment several times, not only getting close to the same answer, but getting close to the same correct answer every time. So I do expect you to know the difference between accuracy and precision. And so here's some examples that I just made up. It says a measurement was taken 3 times. The correct measurement is 46.3 centimeters. So we measure a length of something. Is the set of, we're about to see some examples here. Are we being accurate? Are we being precise? Are we being both or neither? And I usually call accurate really close to like within a tenth or so off of that. Here's 4 examples. Now again, here is the measurement that we're trying to get to, 46.3 centimeters. So here's a group, student 1. You can see that it's 51. They measured once, it was 51.1 centimeters, then 46.9 centimeters, then 45.3 centimeters. So at no point were they really close to this. So I don't see any accuracy going on. And then these numbers are not close to each other either. So that would be repetition. So this would be an example of neither. So neither thing is happening here. So notice this one. Supposed to be getting 46.3, but we're getting 80.1, 80.1, and 80. I don't know what they're measuring with, but they're looking at the ruler awfully bad. So this is not accurate, but does it make sense that their numbers are close to each other, so this would be being precise? So look at this one. Supposed to be getting 46.3. They got 46.2, 46.3, 46.3. That is actually being both accurate and precise. I'll just shortcut it there. And then we've got this one, supposed to be getting 46.3. We're getting 72.1, 60.3, and 68.9. They're not close to each other, so they're not precise, and they're not close to the correct answer, so they're not accurate. So this is another neither. All right, so again, accuracy is getting the right answer. Precision is getting repetition close to the same answer. We really would like you in your measurements to be accurate and precise. So just lets you know. So those we'll look at more in lab. So if you have any questions, please feel free to reach out to me through email, and I'll see you in class.